Hello Year 9. In our final lesson of this week we're going to be looking at inequalities. That's things that are not equal to a value but could be more than them or less than them. So we're going to see how these can be used to represent information, how they can be illustrated using number lines, and looking at the ways that we can solve them. So the four inequality symbols which you should already be familiar with are these ones here. So if I read left to right, whatever's on this side is smaller than whatever's on that side. So smaller than, or more commonly, less than, but also under, etc. So something is under something, something is less than something. For instance, 3 is less than 7. Interestingly, we could also read it from right to left, because 7 then would be on the big side. 7 is bigger than 3, also true. This one here, reading left to right, this side is bigger than this side because it's wider than this side, so we've got bigger than, greater than, which is the most common or the more mathematical one, in the same way that that one is a more mathematical one, more than, over, etc. There's lots of the ways you could use to describe these. So, as we had before, 7 is bigger than 3. These ones at the bottom, this one will be something that is less than or equal to it. So, less than or equal to. And that's used for things like less than or equal to, or at most. So everything up to and including the top part here. This one, more than or equal to. Or again, can be used for more unusual statements such as at least. So if something is at least, then it's that as its lowest point and then more than that. So they're useful for statements like that. Now, a list of numbers which satisfies a description using these inequalities is known as a solution set or a set of solutions. So, for instance, if I was to say x is less than or equal to 3, then any number that I can think of that is less than or equal to 3 would be a solution. It would be in the set of solutions for that inequality. So, for instance, 2, 1, 0, negative 1, negative 2, negative 3.8, etc. So I'd like you to pause the video for a moment and have a look at exercise 10F on page 189 and just do question 1. Should only take you about 5 minutes or so. Welcome back. Our next example looks at statements and being able to use inequalities to illustrate those statements. So this statement here, under 3s travel for free. So let's use the variable, we're talking about ages, so let's use the variable a for age. And if we are under 3, then we must be less than 3. So straightforward enough inequality. And then we're going to use this number line to represent the same thing on this number line. So I know I've got to be thinking about 3 because children are less than 3 years old travel for free. So anything below that, so anything less than 3. all those values below 3. You'll notice that this circle here has not been coloured in. That's because I can't include 3, because it's less than 3. So where I'm not including 3, I don't colour it in. It's a hollow circle. Our next example on the right, bridge not suitable for lorries over 3 metres. So have a think, what height can a lorry be to go underneath that bridge? Well, it can't go underneath the bridge if it's over 3 metres, but it could go underneath the bridge if it was equal to 3 metres or below that. So I will use h as my variable for height. The height must be less than or equal to 3. Now, illustrating that on the number line, I know I've got to have 3, and I know I've got to have all those values less than that. But this time I'm including 3, because if your lorry is 3 metres, it can go underneath. So because I'm going to include it, I fill in the circle to indicate I am using the 3 as well. That's the third example. You must be over 1.5 metres to ride this roller coaster. So we're talking about height again. So height over means you've got to be greater than 1.5. So values of height greater than 1.5. On your number line, find 1.5. Put a circle at 1.5. Greater than means everything to the right of that, everything bigger than 1.5. And am I going to colour it in? No, because I need to be over 1.5, so I am not including 1.5. So I'll leave it empty. And our last one, you must be at least 15 years old to enter the Y factor. What a terrible pun. So that means you need to be aged 15 or more. So we use A for age again. 15 or more means that you need to be greater than or equal to 15. That's that at least phrase again, isn't it? So 15 or more. So circle at 15. Everything to the right of that is greater than 15, and I've got to include 15, so I colour that circle in. You will come across these later on in GCSE, and you'll see these number lines will be equivalent of axes. So you'll start looking at inequalities like this with graphs later on, but for now let's get used to just using the straightforward number lines. So could you please pause the video and have a go at exercise 10F. So question 2 on page 189. Now the last part of our section on inequalities is looking at solving inequalities. This is very much like solving equations, where you carry out the same mathematical operation to both sides. However, there is one difference. Because inequalities have a direction, just go back and look at those number lines you've just drawn. Every single one of them has a direction. So because it has a direction, if we multiply or divide by a negative number, it will change the sign of the number, which means it also needs to change the sign, change the direction of the inequality sign. There's a very simple way of looking at this. If I go back to my, what do I have, 3 and 7, I think, so 3 is less than 7. That was one of my examples from the first page. That's true. You know that's true. If I multiply both sides by -2, then I get -6 is less than -14, which is not true. Negative 6 is not less than negative 14. However, negative 6 is more than negative 14 would be true. So when I times both sides by a negative number, I need to change the inequality sign round as well. Okay, so we're going to have a look at the example that is on page 188 in Caboodle. However, there is a typo on the page. It says there on the book, in the book it says 5x plus 5 is greater than 2x plus 1. It's incorrect. It should be 5x plus 5 is greater than 2x minus 1. So I'm going to do the correct version of it. So first of all, solve the inequalities and represent the solutions on a number line for those two things. I'm going to do, and I'm going to add an additional one as well. I'm going to do this one as well. 3x take away 1 is less than or equal to 2x plus 3. I'm going to have an additional one there. So, first of all, part 1. 5x plus 5 is greater than 2x minus 1. And we solve it. As I said, the process is the same as it would be for solving linear equations, which is the first thing you did in this unit. So I'm going to collect all the x's on one side. This side's got the most on it, so I'm going to take away 2x from both sides. 3x plus 5 is greater than negative 1. Then take away 5 from both sides. 3x is greater than negative 6. Divide both sides by 3. X is greater than negative 2. So I've divided by a positive number. Adding and taking away numbers doesn't make any difference. It's only when you divide and times. So x is greater than negative 2 is my solution. And on a number line, that would be this. So I've lost my ruler. Oh well. Negative 2, negative 1, 0, 1, 2. You don't need very many things. But the number is hollow. Sorry, the circle is hollow because I'm not including the number, and I want bigger than that. So there's my solution on the number line. Two. Negative 5y is greater than or equal to negative 20. So in order to work out what y is, I need to divide by negative 5. So I'm going to divide by negative 5. So I'm dividing by a negative, I change the sign. So it becomes y, and negative 20 divided by negative 5 is 4. And because that is negative, this changes round to that. And if you're not sure, pick a number in this set. Let's see, what number is less than or equal to 4? Let's pick 2. Negative 5 times by 2 is negative 10. Is negative 10 greater than or equal to negative 20? Yes, it is. So you've got it the right way round. If you'd have got that the wrong way round, when you tested it, it wouldn't have worked. And my number 3 here, got my number line. My number line 4, 3, 2, etc. Circle at 4, everything less than 4, and then 4 is included as well. And then 3. I'm running out of space. Down here. 3x take 1 is less than or equal to 2x plus 3. So collect both things on one side. Take 2x away from that side, I end up with x. Take away 1 is less than or equal to 3. So x is less than or equal to 4. So that number line. Very much like this one here. And I forgot to write it down, but the final part of part A, my additional example, was find the set of values that satisfy part 1 and part 3. So these are the set of values that satisfy part 3. These are the set of values that satisfy part 1. If I put all those together on one number line, oops-a-daisy. Can't count. And this one is all those, and this one is all these. So the set of values which satisfy that inequality and this inequality are, I've missed a word out, integer values. So integer, whole number, that would be, not including -2, it will be -1, 0, 1, 2, 3 and 4. Those numbers satisfy both of those. Now our last example part B. Find the integers which satisfy 2x is greater than 10 and less than or equal to 17. Now this is something you can't do with an equation. Have 3 sides. But it's exactly the same thing as before. I need to work out what x is, which means I need to work out what 1x is, so I have to divide that by 2. I divide that by 2, I divide that by 2, I divide that by 2. So dividing by 2 to get x, and I get 5 and 8.5. Straightforward as that. Could also have something that looked like this. And we do exactly the same thing as it would do if it was that. We take away 1 from everything and divide everything by 3. So taking away 1 gives me 3x, 9 and 21, and dividing by 3 gives me that. So that's all the examples and a few extras from Inequalities, section 10F. So I'd like you to spend the rest of the lesson doing questions from 10F, questions 4, 5, 6 and 7. You don't need to bother with question 8 on the problem solving. So until next time, bye bye.